So, today we are here to discuss about the new subject, that is basic signal and systems, that is in third semester of electrical engineering. Myself Saurabh Kumar Jha. So, today the first lecture in which we will discuss about the course outcomes and syllabus, which is consist of 5 different units. So, in the further slide we will discuss what we have to cover in this syllabus and what are the outcomes after completing the syllabus. Okay. Now, let us proceed. Okay. So, before starting the subject demand one should have a knowledge of basic electrical engineering, that is a course you have studied in the first semester or maybe in second semester, means that in first year. So, the subject which is required to be studied before the subject is basic electrical engineering and engineering mathematics. So, in basic electrical engineering, why it is required? See, basically when we talk of a signal, so it we will be representing a signal in form of mathematical equation. Whenever we represent it in a mathematical equation, we must require some knowledge about that. For example, suppose if I write V t is equal to V m sine 100 pi t plus 30 degree. So, if I write something like this, so you must be knowing that what are the different components represented in this equation represent. For example, if I ask what is the amplitude of this signal in the given equation, so you can tell the amplitude is V m. If I ask what is the frequency, so we can say what is the frequency, we can say frequency is 50 hertz. Similarly, if someone asks what is the lead angle, lag angle, then we can say this is the angle. So, this is the basic form is A m sine omega t plus phi, where phi is the angle of lead or lag, omega is the representation of frequency, and A m is the for amplitude. So, we will be going on the first lecture discuss about the syllabus, and once we discuss the syllabus in detail, then we can have a very good idea about what are the different COs. So, we must also understand what is course outcome. See, when we are going to study any subject, so we must know that after completion of that subject, what knowledge we are going to acquire. For example, suppose if you have studied basic electrical engineering, that means at now I mean current time you are having a basic knowledge of all the electrical components or different circuits, different theorems, laws we have studied. So, similarly course outcome means what knowledge you are going to gain once the subject is complete. Okay. So, basically we have divided this course into 5 outcomes. So, these are the various 5 outcomes, and once we discuss about the detailed syllabus, then we will be having, then we can easily recognize this course outcomes. So, let us go to the detailed syllabus. Okay. So, the syllabus is divided into 5 units. So, first unit is introduction to continuous time signal and system. So, basically as you can see, the subject is having 2 major terms, that is signal and systems. So, how can we differentiate what is signal, what is system? So, the very common form of signal. So, if I ask you what is signal, so you can say or we can say that anything which is having some information is a signal. For example, suppose I am taking class, and there are students around me. If I ask a student, if I give a signal like this, that means I am asking a particular student to stand up. Similarly, if I give a signal like this, so that means I am asking a student to sit down. That means I have not spoken any word, but through a signal I have given a proper message, or you can say a uniform message. Similarly, what is system? System means suppose if you give an input and you get an output. So, there must be some difference between input and output. So, the change of input into output is done by a system. So, that system will define its property. So, what can be systems? For example, suppose if there is a water geyser, and what do you give? You give basically, you can say cold water during cold season as an input, and what you receive? You receive a hot water as an output. So, just by seeing the input and output, we can easily say the property of the system. That means, if I am giving cold water and I am receiving hot water as output, that means the system must have done the work of heating. That means this system must be having some element which will be transferring heat to the cold water. So, system, so by seeing giving the input and receiving an output, we can tell the properties of the system. Okay. Now, first point is in the syllabus it is introduction to continuous time and discrete time. So, what do you mean by continuous discrete time? See, if you have a signal, if you have information, if you have message throughout a duration without any lag or without any time lag, so that is called as continuous time. And when we have any signal in form of some interval of time or for duration of time, or there is some time in which there is no signal. For example, suppose if I have to draw a continuous time signal, so I can represent a signal like this. Suppose it is signal is starting from time 2, so time t, and this is the message signal. If it is going like this till time t, so we can say this message or this signal is continuous, as it is having a value for every point of time. There is not a single point throughout the duration in which the signal is not having any proper signal or any proper message. Similarly, but if we give a signal like this, suppose so this value is 1, this is time, you can say this is 1, 2, 3, 4. So, what does this mean? This means that this signal is having message or information only on particular duration or particular time. So, this is basically an example of discrete time. When the time is not uniform, it is divided into different intervals. This is difference between continuous time and discrete time. Now, the next thing is classification of signal with their mathematical representation and characteristic. So, what is classification of signals? Suppose now we have discussed our signal. So, the signal can be of different type. For example, in we will study there is power signal, there is energy signal, there is even signal, we have odd signals, we have periodic signal, we have non-periodic signal, then we have many properties, many other properties. Similarly, how we are going to represent an odd signal, how will we represent an even signal? For example, suppose if I take example of even signal, so if I say even signal and if I represent this signal in form of graph, so I can say if a signal is like this, suppose this is the time, and this is the magnitude, then this signal is example of even signal, because this is symmetric about y axis. Let it make it symmetric, this is not symmetric. So, for even signal I can say so if a signal is symmetric about y axis, so we can say that signal is an even signal. So, how can we say that? Okay, so this was the representation in the form of a graph or form of a on a axis or on a plane. But if we want to represent this in the form of a mathematical equation, see, because so how we can write in the form of this was the now if we want to represent in the form of mathematical representation, what we will do? We will simply write xt is equal to x to the power minus t. What happen if I write xt? So, we can say this is the mathematical representation of what happen means whatever is the signal at the time of positive, similarly the signal for minus t. That means, so this is the representation of this graph in mathematical form, and this is the representation in graphical form. Similarly, if I draw a signal like this, so what is this? I can say this signal is an odd signal. So, if you try to find out the symmetricity, so this graph is or this figure is symmetric about what? Is symmetric about origin. So, whenever a signal is symmetric about origin, so we can say the signal is a what signal? Odd signal. And again we come to what is the mathematical representation of this odd signal. So, mathematical representation of odd signal is, how can we write? See what is happening, whatever is the value of signal in the positive half, in the negative axis the magnitude is just reversed. That means x t is equal to minus x to power minus x into minus t. That means value of signal in positive axis is equal to negative of the signal in the negative axis, and negative is in the for what? Magnitude reversal. This if you further if you study in detail, then we can say this is amplitude reversal. In the original signal amplitude was plus, and in the negative signal amplitude was negative. This is also called as amplitude reversal. Okay. So, this is the mathematics. This will be studying about how we represent mathematical and through graph in signals. Okay. The third topic is introduction to various type of system and basic system property. So, as we were having the type of signal, different type of signals, similarly we are also having different type of systems, and every system will be having some properties. So, that we will study, that is causal system, then we have time variant systems, then we have linear systems. So, these are what? These all are the properties of a system. So, we will study this in detail. What do you mean by causal system? What do you mean by time variant? What do you mean by linear system? Okay. So, again, see, if you want to know what is linear system, so you must be knowing about the what is homogeneity principle, what is superposition principle. So, this is both the requisite for knowing what is linear signal. So, this what is covered in basically basic electrical. We will also discussing this part in where we will discussing about the system properties, but we must be aware of all these 4 topics. So, this will be covered in the basic system properties and basic systems type of system. Now, further moving further, we have what? We have analog system. See, it is very easy. For example, we have also studied transducers. So, in transducer what we have studied, that what we do basically in electrical transducer, what we do, we basically convert any form of input or any form of signal into electrical. For example, suppose if you want to measure a pressure. So, if you want to measure pressure, so that there will be some device which will be measuring the pressure, and if you say about electrical transducer, so that measurement of pressure basically will be converted, that measurement will be converted into an electrical measurement, and then we will process the signal. Similarly, in this, when we say that in analogous system, what we do, we take a mechanical system and we convert that mechanical system into in the analogous to the electrical system. For example, suppose in mechanical system we have force. So, in electrical system, how we will represent this force? So, mechanical we will have force, we will have torque, we will have having displacement, we will be having velocity. So, basically these forms are what? Mechanical forms. But now if we want to draw analogous system, so there is a provision in which we can convert this into 2 model FV and FI, force voltage analogy and force current analogy. They are basically 2 analogy in which we convert this signal into this type of input into electrical system. So, this is will be covered into analogous system. Now, we are coming to unit 2. Unit 2, this is Fourier transform analysis. So, now whatever you study is you are giving an input and you are getting some output. Suppose you have got this or we can say till now what we have studied is we are studying everything in time domain, xt, yt. So, but if we want to analyze the response of a system for different frequencies, that is through various method, that is Fourier transform, second is Laplace transform. So, these are the various tools which help us in having a frequency analysis of a system. If we are analyzing a signal which is having some frequency and we are trying to analyze its frequency analysis, then these are the various methods which will help in doing it. So, in Fourier transform analysis, what we have here, we have what exponential form, compact form. So, there are various form of representing. So, okay, before Fourier transform, what we here we have is Fourier series. So, what is difference between Fourier transform and Fourier series? See, basically Fourier series is used for only periodic system, periodic signal. If we are having any periodic signal, so we know that a periodic signal can be easily represented in the form of summation of their harmonics. For example, if we have sin omega t, so we can say sin omega t is what? A periodic signal. Sin omega t is a periodic signal. So, we can easily convert sin omega t, we can easily present sin omega t in form of sin omega t plus sin 2 omega t So, when a periodic signal can be easily represented in the form of the summation of their harmonics. Okay. So, for periodic signal we will have Fourier series, and for aperiodic we will having other methods. Now, again that only we will be studying what is Fourier symmetry and Fourier transform. Again we will having properties of Fourier transform, in which there are some properties of Fourier transform through which we can easily say that this will be the condition for which this is a property by which we can simply write the final result. In the Fourier transform also you will be studying about the initial value theorem, final value theorem. What is initial and final value theorem? This is a method through which, if you know that xt to x omega, this is basically what? Conversion of time domain to frequency domain. So, this is can be done by Fourier transform, Laplace transform. So, if you know the initial value in one domain and you are able to convert that in other frequency response, so you can know the initial value in one domain. So, you can tell the final value in other domain, or you know the final value in one domain, you can say the initial value in other domain. So, this is also a initial tool which is called as initial value and final values theorem, which is in this course. So, similarly we have Fourier transform, we have Laplace transform. So, what is difference is okay. So, this is a review of Laplace transform, property of Laplace transform, initial. So, here what I have discussed is initial and final value theorem. Okay. So, also what is inverse Laplace transform? So, Laplace transform xt into x omega. So, inverse Laplace will transform x omega into xt, means conversion from time domain to frequency domain is Laplace transform, and conversion from Laplace domain or frequency domain to time domain is what? Is basically inverse Laplace transform. Again we have impulse response. What do you mean impulse response? See, if we define signal, so in signal we have basically the very common signal as, this is called as step signal. Then we have a impulse signal. Third is a ramp signal. Then fourth we can have, see, we have parabolic signal, we have a ramp signal, this is impulsing signal, this is a step signal. So, these are basically 4 different type of elementary signal, and out of these 4, this one is what is called impulse signal. We will be using this impulse signal as most of the places, because, so basically what is impulse response? Impulse response means when a system, there is one system, and when the system is provided with impulse as a signal, when a system is provided with impulse as a signal, so what response you get is called as impulse response. So, and when we take Laplace of impulse response, then we will be able to define the transfer function. So, all these terms will be coming in the further. So, this I was discussing only about the impulse response. When we provide impulse as an input to the system, we will have impulse signal. Again we have application of Laplace transform to analysis of network. So, suppose if I am having R, L, C and in a circuit. So, if I ask if there is one supply and if I ask you to find out the current. So, basically this is R, L, C. So, if we solve the circuit, we will write as V upon R plus X L plus X C. So, there is one way to solve this circuit in the time domain, and similarly the Laplace transform help us in solving the circuit in another form. So, we can write this as R S L 1 upon S C. So, if we change this circuit into Laplace form, then we will write R as this. So, if now it is easy to solve this circuit writing this thing, otherwise. Okay. So, this is the another use of Laplace transform. We use this for solving a complex network in a easy manner. Then we come to state. Then we come to state variable. So, basically till now what we have done, we have not discussed about. So, when I was discussing about the property, so there was property was linear time invariant system. We combine these two properties, linear and time variant. So, we comes to a system called LTI system. So, most of the operation are done on LTI system, that is linear time invariant system, and Laplace transform can only be found for what systems? LTI system. Okay. So, that means Laplace transform is for only LTI system. If we now, and if we know, if we have the Laplace transform, we can easily find the transfer function, because transfer function is basically ratio of Laplace transform of output on Laplace transform of input. So, once we have this, we can easily study the system, but if we do not have this linear LTI system, then it will be very difficult for us to analyze the system. So, state variable analysis is a tool which help us study a non LTI system. If you want to find the stability and other thing, we can easily find for a non LTI system. This is basically the tool through which we can study a non LTI system. Now, so till now what all we have studied were about the discrete signal. Now, suppose whatever we have studied, frequency domain or response in a frequency domain, that was for continuous time. Starting itself we have studied, whatever we study, we will be studying for two type of signal, for continuous and discrete. So, if we have discrete signal, so for discrete signal what we will be doing, we will be having, this is Z transform analysis, this is basically for a discrete signal. So, same thing is here also, we will have a discrete system, and for which we will be finding about the Z transform, that will be in the frequency domain. Then again inverse Z is basically when we convert x z to x n, that is inverse Z transform. Similar is the initial and final theorem. Okay. So, after we have studied this, we can easily now realize whatever the CO. So, CO1 was basically representation of variety of signal system, which was in unit 1. Then we are having analyzed the response of LTI system. So, Fourier series and Fourier transform, if we have, once we have LTI system, we can easily identify using this tool. Then we have analyzed the properties of continuous time signal and system using Laplace transform. That is basically in unit 3 and 4. Then we have CO4 implement the concept of Z transform to solve the complex engineering problem. So, this is for basically, these were for basically what? A continuous time signal, and again we will having Z transform for what? Discrete time signal. At last we will be having CO5, where we will studying about the state space model. Okay. So, why we study state space model? Because all this analysis can only work in LTI system, and but if we do not have LTI system, we can only use one tool, that is what is called as state space model. Okay, so in next lecture we will be studying each unit in detail, taking different signal or whatever is the principle. We can study each topic in detail in the further coming of lecture. Okay, thank you.